Hello everyone. Today our fraud workshop with AWS and Women in AI. My name is Anna Silvanen and I am from Women in AI. And it is the topic of our workshop today, large language models and generative AI. So we have also the last workshop next month, and the topic is responsible AI. Here you can see QR code for our Eventbrite collection and for all workshops. Our recording will be published on our YouTube channel, and we will put the links in Q&A session later during this workshop. Here is the topic. So the first speaker will be Markku Leppala. I have another slide here. Yeah, from Emblica. He is a machine learning engineer, and Venla, who will be Marco Venla, also from Emblica, and she will help us today. And we have Anna Maria Todor. She's AWS solution architect, and we have also Miguel from AWS. He will help with labs. And I think do we have also Miguel? Do we have other people from AWS today?
Yes, we have Mark, who is already in the call. Mark, you can show your face if you are here. And Xiao, you will probably join later for the labs.
Yeah, thank you. So here's the agenda for this day. At first we have introduction, and after that it will be Anna Maria Todor speech, and we have 5-minute breaks. And after 2 o'clock we have labs. So we have maybe 2 breakout rooms, and we will put these links later for our workshop and labs. In this session, we will use Q&A box. So if you have some question during the main presentation, just write your question there, and our experts will answer the questions. And after this break, we actually don't have any main room, only these breakout rooms. And if you want to ask some question there, so you should unmute yourself or just write in the chat. My last slide, it's about this challenge, AWS challenge. And if you not yet join it, so please join, and you can have actually 50% discount on your certificate exam. And I think Marco can start. People still join our workshop, but we have a recording, so I stop my sharing.
Right, let me know if you can see the slides.
Yeah, we can see.
All right.
Thank you, Marco.
Oh, let's get going then. Yeah, well, nice to meet you all. My name is Markku Leppala, and thanks for the introduction. And pardon me if I feel a little bit laggy here, so I just came back from work trip to Nigeria and trying to survive from the acute food poisoning, but Venla here is covering me just in case I need to run for some affairs. And one might ask, what does a data and AI consultant do in Africa? But I think AI and similar tools are the ones that could leapfrog the IT infrastructure of these developing countries, and also will be the easiest way to help the lives of people and the daily tasks. But yeah, let's get to the topic. There's some ground to cover. The slides are then shown in the case that there's some references and links, so you can then access these later on. So the outline for today is that let's go to the intro of LLMs, take a look at some open source foundation LLMs, and then grasp the surface of the fine tuning and take a look at what after these ones. And there's some time for questions and answers if you have any. So the introduction to LLMs. So let's start from the early on. So kind of as the first chronological trend here, we had the classification. Classification is a supervised machine learning process of categorizing a given set of input data into classes on one or more variables. So we have an example here of the famous cats and dogs data set. And here, what the supervised means is that we have a label for cat or label for a dog that we can then use in the loss process and training the model. And the classification can be also for any other data, such as email spam filter, hate speech recognition, or product recommendation. So it can be anything else than just picture or text. And here also some examples of some early data sets and competitions around the topic. Well, kind of as the second trend we are currently experiencing is the generative AI. So generative AI refers to deep learning models that can generate high quality text, images, or other content based on the data they were trained on. And some early examples here are maybe the most famous one is the image-to-image translation with CycleCAN. And as the at the bottom picture here, we have the example of that one. So we have a original photograph of the field with some flowers in it, and we can ask the model to apply the style of Monet or Van Gogh in it to get the kind of more stylish picture. And the second example, we have the reconstruction of image with missing parts. And you can see actually that currently in use already some photoshopping tools, as there's the healing, the kind of tools that could reconstruct the image. If we want to, let's say, cut something out and reconstruct it back, these kind of tools are already applied there in the public. Then we also have some other examples, but I will give your own time to take a look at those ones. But the generative AI can also be anything else than the images. So we can have some game agents or even the audio here. And as kind of like understand the kind of how this all is related in relation to the machine learning and deep learning. We have this picture on the right-hand side. So the kind of the wider topic here is the machine learning, and under that one we have the subset deep learning, and then the generative AI is the subset of the deep learning. And yeah, so and the topic itself. So the large language models. It's also a generative AI subset using deep learning algorithms that can generate, summarize, translate, predict, and generate content using very large data sets. So based on the name, like the models are trained with massive amount of text data. So those can be varying from terabytes to even petabytes, and thus the name large. And just to get some idea of the content itself, here's some Meta's Llama 1 example data sources. So we've been using mostly data from the common crawl websites, but then also from some other sources such as the open source repositories for GitHub, Wikipedia, some public domain books, and latex from source code from Archive and Stack Exchange comments and conversations. It's good to keep this one in mind. Now we will come back to this on the fine-tuning phase. And here one of the most important things is to kind of minimize the training data bias and profanity. Well, how these large language models are then created. So first, we collect some massive amount of data. And then, as in any data science applications, we want to put high effort on the data cleaning and filtering. So in example, removing the low quality data, filtering the overlapping content, and removing the possible bias. Then we will do this trick called tokenization. So it's a process of splitting the input text into smaller units that can be then processed by the LLM models. Here's the picture. Here is an example of the GPT-3 tokenizer. And these are just an example of two, pretty much the same phrases of some moving. And here's an example in Finnish and also in English. And you can see an interesting factor here is that the tokens are slightly longer in the English text than in Finnish text. So it can also gives idea that what are the main priorities of these models. Well, then after tokenization, we will select the model architecture and train the model. And as in any machine learning projects, we will evaluate the trained model and iterate the training data of the hyperparameters. And these models we create from scratch, so from this data we collect, are called as foundation models. And it has pretty much the same process with the pictures. So first collect the data, then filtering and cleaning it, select the architecture, choosing the hyperparameters, training model, evaluation, and if needed, we want to retrain the model, and depends on where we find the model lacking, we can go back to the earlier steps. Let's have a quick look also like the element details. So here's a datasheet of the Llama 2 model, and maybe the most important ones here are the model size. So when we have the LLM model, those are usually mentioned by the model size. Well, and some Llama 2 here is an example of 7 billion, 13 billion, and 70 billion trainable parameters. So all these kind of models have different applications, but the bigger the model by the parameter size are, the better it performs, but are slower and more expensive to run. And also take some more resources. And for example, some chat models that don't require that much of that many parameters, but then some long text, some models that want to create high quality output text then might require a bigger model to perform better. And then we have the pre-training tokens, and that's just another way to mention the size of the dataset, the original dataset size. And then we also have context length, so how many tokens or words that the model can take into account when making predictions. That can be thought pretty much as the memory of the model. So how much does it remember the context and the previous conversation when making the new predictions, right? So then could kind of have the pros and cons of the model. So where the LLMs are currently great at is like some really like simple language tasks, such as like question answering, translation, content generation, working as a chatbot, generating some code, grammar and style checking, and sentiment analysis. So they can understand the language structure of the language and kind of sentiment it. But so that really works on really good on that one. But where they fall short is kind of generalization outside the training data. So the models in the end don't have deep understanding of the topic itself, and instead of that one just argue to memorize stuff, and really lack some creativity here. So like example here is that although like the model might excel in one test, doing minor changes to the test itself might lead the model to perform really bad. And as I started to create the slides, of course, many things have changed. So yeah, I tried to do that also, like some steps that we have been in the progress. We have had in progress, but currently the large language models are still yet a single model. So meaning that they can only have one medium in hand and be usable. But of course, that has changed a little bit since the ChatGPT announced support for audio and images. And the model details are known as the ChatGPT is like a not open source, so one could call closed source model. And the LLMs are not general AI. So here's one reference for one interesting article. You might want to take a look at later on. And the most important thing to remember from here is that the LLMs currently only know what they are taught with. So, but although some models can use the model internet for searching the answers, so being at least the BART in Bing, and then ChatGPT currently also can use the internet. So that kind of changed a little bit the paradigm here. Well, let's have a look at the open source foundation LLMs. So open source software is software developed and maintained via open collaboration and made available typically at no cost for anyone to use, examine, alter, or redistribute however they like. And so this is a list of open source foundation large language models. And as a comparison, then the other one, then we have some models that are not open source or closed source, such as the Palm 2 and GPT-4. And what is interesting here is that open source model weights are shared and free to use. So there are, of course, all the different models have different user agreement, but some are allowed for commercial, even for commercial use. So you could create some application on top of these open source models and try bill for the usage. But some are only for research. So that's really important to remember when if you're thinking about monetizing this kind of applications. Also, the fundamental, so these open source foundation models as a recap can know the language and perform the NLP tasks. They only know what they are taught with, and usually they are not kind of fluently multilingual. So they perform better on the major languages, and the kind of performance is less frequent, not that good in the less frequent languages. So, for example, because the importance of English in these models is way bigger than Finnish, so you might get even better results in English here. And if the model is mainly trained on text, it doesn't specify for code. So if you can remember now the list of the Llama 1 training sources, so those were mostly just like books or Wikipedia or some website crawling, and maybe 10% of that one was coding. So in order, if we want to have like these kind of models for really specific use case, they require fine tuning to get the better performance. So let's get to the most important stuff, that is the fine tuning of these models. So initial fine tuning is taking the pre-trained model, so it could be a foundation model, and training it at least on one internal model parameter, such as the weights. And in the context of LMS, this is typically to get to accomplish the model to perform better in coding or any other particular use cases. And the benefits are massive here. And a fine-tuned model can perform greatly on a bit smaller model size. And what we get here is that as we have smaller models, it's less computing required and also less emissions in the case. And example use case have been chatbots. So this can perform really well with the 7 billion model parameters instead of the 70 billion. And there also, as you have less, the smaller weights to take in account, it's faster to respond. So we have to really think about what is the application we want to use this for when selecting the model. And also, as an example, the model can be taught with some like context-dependent information. So if you have like company internal chatbot, you wanna let the chatbot know what are the company-related stuff, so they can answer with the correct information. And also, the code assistant can be taught with less known code languages. to perform better in, let's say, some COBOL assistant. There is some kind of interesting articles listed here, but one is the McKinsey Research Assistant that is taught with some curated case documents that could help the other consultants with their case examples. And then also the Llama Python is the Python-specific Llama 2 version. And also Bloomberg GPT is the it's a kind of financially with extensive NLP model. And the steps here are a little bit different than with the general when creating the LLM. So in the first step, if we want to fine-tune an LLM, we want to select the foundation model. And as a baseline, we want to test inference before training. Then we want to prepare the training data set. So this could be some code example. Well, say if we want to do some code-specific model, we want to get this kind of coding data sets, code data set. Then, of course, the same parameters, having the hyperparameters, train the model, and then we want to could evaluate the model and then retrain if needed. And if we're happy with our fine-tuned model, then we can just deploy that one to the user. And here's actually one nice example for the AWS SageMaker notebook. So breaking these steps down in as a Jupyter notebook. And you will grasp these topics later on with the workshop, I assume then. But then, what about the future then? So currently we have a look at the first two phases. And currently, the step we are also moving towards with this generative AI is the third phase, so interactive AI. And what this terms in my mind actually means is that the systems can communicate with their other AI systems or applications and search the data from internet. So actually, an example task we could do with the interactive AI is that make a reservation for the next month's dinner event based on my calendar to one nice African restaurant, and also make an invite letter with cover photo, send this to attendees, and ask for my confirmation before proceeding with any step. So in this case, we could have the one model working as an agent that then like executes these tasks with other public APIs or other machine learning models. So and also we are now currently closing the gap towards these ones with the ChatGPT and BART plugins and the internet access. So this is definitely one interesting field to take a look at. That what are the next things happening in this after the generative AI we are currently experiencing. But yeah, that was pretty much all from my side. So happy to answer some questions. And yeah, happy to answer the questions here. And so please let me know.
We have one question here in Q&A session. So it is, what exactly do the parameters do, and doesn't larger parameters make the model prone to overfitting?
Yeah, so well, the parameter, well, in the AI, I usually have the parameters only just floating variables. So of course, it depends how the model is structured, but the parameter is just like a way to know the relations between different topics. So if we have one word, if we get the model, we get to one. It's, yeah, I could say that parameters are only just probabilities. So if we have input, we have these 5 words as an input. Based on the parameters, we can iterate that what are the next possible, what other words has the largest possibility to continue, to kind of complement the first 5 words. So basically, it's just probabilities that what would happen next, and kind of knowledge, but it's kind of like condensing how we condense the information into information of everything and the relations. It's a bit, yeah, it's a definitely abstract concept. So, and even I'm not the best person to answer maybe that one, because it's still also model dependent.
Yeah, thank you, Marco. We have also another question. So what has been the most difficult thing with large language models when training or deploying them?
Well, I think one of the challenges here is that the training process is extensive. So you need a lot of resources, like to measure the for the develop to find even fine tuning. It takes some resources and creating those ones. And maybe one of the challenges is also with the LLMs that those are still like in a way black boxes. So we don't have really that much information that what do these different parameters do, and because it's not that clear into like a larger picture. So it's called more like try and error.
Yeah, thank you, Marco.
You're welcome.
So it was very interesting presentation. Thank you. And is it now the turn our second speaker? So Anna Maria, are you ready?
Yeah, I am ready. So let me start by sharing my screen. All right. Can you see my screen?
Yeah.
Perfect.
Thank you.
So now that Marco has actually done a very good introduction into large language models and generative AI, I will go ahead and talk a bit about the more practical aspect of generative AI. So basically, how can you use them to create a robust application? And of course, I'm going to mention some of the AWS services as well, because you're going to be using those today in the labs that will follow. In terms of introduction, yeah, my name is Anna Maria Todor. I'm a principal solutions architect based in Copenhagen in Denmark, and I've been with AWS for roughly 3.5 years, focusing a lot on machine learning and helping customers navigate the different capabilities of artificial intelligence. And of course, now with generative AI coming up, I'm trying to also help them navigate this up and coming service as well. So, what are we going to talk about today? First, I'm going to talk a bit about what options you have when actually using foundation models on AWS, because there's a wealth of options, and depending on your use case, you might go with one or another. I'm also going to talk about some of the challenges that generative AI models bring and how you can guard against them, and also how to add external data to generative AI. We're going to talk about why that is necessary in a moment, as well as how you make generative AI interact with external tools. Like Marco mentioned that, for example, ChatGPT can now, and Google Bard can now access the internet. So we're going to touch a bit on that aspect as well and how it is possible to do it. And last but not least, I will share some tips and resources at the end if you want to dive deeper into the topic. So generative AI is great, right? It can help with so many tasks in automating things that we have to do over and over again. So for example, you could ask a generative AI model to write a presentation, or at least an outline of a presentation for what I'm showing you today. And it will do a pretty good job at providing the set outline, right? Thinking about an introduction, telling me to mention a design pattern, architecture principles. So it's definitely really relevant in what it's saying. However, there's also a lot of challenges with large language models, because they were trained first and foremost with a cutoff date, right? So they do not have information of the world that is updated in real time. So if, for example, I'm going to give a large language model my name and ask it to complete the sentence, as you're seeing here on the screen, I'm telling the model that, hey, I joined AWS in 2020 and I'm a solutions architect in Copenhagen. And then I ask the model to try to guess what my major accomplishments are. It might get some of it right, like the fact that I do work in the healthcare and life sciences industries and helping customers to scale, but it might get some other things wrong, such as the fact that I studied at the University of Munich, when in fact I finished at Copenhagen University in Copenhagen. And this is because the large language model does not really have information about me, and it will try to come up with whatever statistically is the closest thing to the truth, but that might be very far from the actual truth. And this is a very common problem, referred to as hallucination, and it's something that if you start developing applications with large language model, you will most likely encounter on a day-to-day basis. And of course, it's not only that, there's a lot of challenges with large language models. One of them is also toxicity. Large language models do have a tendency to show swear words from time to time, and it's good to guard against those. Happily, you can do it quite easily by providing input and output filters. And then, of course, I just mentioned hallucination, one of the most prevalent problems. And these too can be solved by supplying relevant facts and information with the prompt that you provide to the model. And last but not least, the models themselves have limited knowledge, so it's good to find a way to actually augment that knowledge with external data sources. So by writing agents that can fetch the correct data based on the question that the model gets. Having all these use cases in a bit more detail, because the goal is to have an application that's based on a large language model, which is harmless, helpful, and honest, right? So we don't want anything out there that goes rogue and swears at people and hallucinates about rainbows and unicorns. That would not be a very helpful application to build. So in order to dive deeper into this, we need to understand the generative AI project lifecycle a bit. So if you want to build a generative AI application, what are the actual steps to get there? So first and foremost, of course, you have to define the use case. Of course, generative AI is a very attractive technology, but that doesn't mean you can use it for everything or anything. So even before deciding to go with it, you have to define your use case and you have to do a reality problem. And once you have that figured out, that's where you start looking at the models that are available out there, be them open source or proprietary, and you choose a model that best suits your use case, right? Because you have text-to-image models, you have text-to-text models, you have models that are better with code, or other models that are better with multiple languages. So there's a lot to look at, right? And of course, there might be no models out there that just fit your use case perfectly. So then you might also choose to pre-train your own model. And then you enter the adaptation and alignment phase. And again, depending on what kind of model you chose, this could be anything from just providing a few prompts to the model, to doing fine-tuning with additional information, to aligning the model with human feedback, so having like a sort of automated feedback loop, and also evaluating the results of the models or the responses of the model in the context of your own application and what you're trying to achieve. And then, of course, once you're happy with the model itself and its performance, there's the step of deploying the model in production and optimizing it in the wild, right? And of course, in this session, we're not going to focus on the first part of things. We are going to touch on some prompt engineering in the labs, and also on fine-tuning. So I will leave it to the lab for that part. But for best practices and for the scope of this presentation, we're going to talk again about application integration and how we actually tackle some of the challenges that I mentioned. So let's talk a bit about how do you go with using foundation models on AWS? So the first option, and definitely the simplest option you have when using AWS, is to use a service called Amazon Bedrock. So Bedrock is a very high-level service. It's actually what we like to call a serverless experience. It exposes an endpoint, and behind this endpoint, you have several models available. And they're models provided either by AWS or by third-party model producers, everything from AI21 Labs, Anthropic, Stability, or Cohere. And you do have the option to also customize these models with your data. Last but not least, because it is a service that's part of the AWS ecosystem, it also has deep security controls embedded in it. And it also works extremely well with the other AWS services. But for the most intents and purposes, Amazon Bedrock is just an API endpoint that you can call with an internet GET request, and you will get the response from the model. Everything else, you don't have to worry about hosting the model, how much memory you need, how much compute. Everything is taken care of for you. And as I mentioned, there's a lot of models already available here, both text-to-text and text-to-image, also something we call text-to-embeddings, which are more like used for search. So you see all of them listed here on the slide, and there's other coming as well in the near future, like, for example, the Facebook, the Meta Llama model will also be available quite soon. And we are evaluating new models continuously and adding the best ones on the market, the state of the art, as we go. Besides that, you also have the option to go with Amazon SageMaker Jumpstart. So Jumpstart is a foundation model hub where you can browse for different existing models that are available out there. You can experiment with them on the fly, and you do have a bit more flexibility around customizing the model before you deploy them out there in the wild. Now, what SageMaker Jumpstart brings over Bedrock, so besides the level of customization, of course, is a much wider net of models. I mean, you can see that here on the slide. It's a lot more models. Some of them are open source. Some of them are also provided by third-party providers. The other difference, though, is that you do have to think a bit more about how you're hosting the models, because you need to think about what hardware the models are going to run on, and how the endpoint will basically behave to your request, right? So a bit more overhead in terms of handling the models, but also a bit more customization and power around controlling the models themselves. And there are 3 ways to use the SageMaker Jumpstart. You can use them. You can use the models in Jumpstart from SageMaker Studio, doing a simple one-click deploy. You can also play around with them in SageMaker Notebooks, and this is what we're going to look at today in the labs. And you can also access them directly from the AWS console. So you might be asking at this point, which option should you use, right? And if you've been following along, obviously Amazon Bedrock is the easiest way to start. And this is definitely the service with the gentlest learning curve as well. Today, we're going a bit more advanced, though. So we're going to look at SageMaker Jumpstart, because we also want to touch a bit on custom training and just to see the differences between a model as it is out of the box and what you get by fine-tuning it. But of course, if you want to go full custom and you know what you're doing and you're a data scientist, ninja, you can also go with just hosting your own infrastructure, doing the training on EC2 instances, and compute resources like in the clear. That is also the most advanced option, but maybe also the one that gives you most control, especially when it comes to accessing the hardware layer used for training the models and also for inference. So now that we got that out of the way, so let's talk a bit about architectural patterns that you can use in your applications to get around some of the challenges that I've talked about when it comes to large language models. So if you remember, the first thing I mentioned is toxicity, right? You don't want a large language model that talks foul language. The one thing you can do is to actually use other AI services as safeguards. So if you think about classical architecture that would involve an application exposed to the internet, that would look something like, going from the user the user would go through some sort of UI that you either bring yourself or you build in React or Angular, or you could also use a service called Amplify that we have in Amazon to kind of really speed up your development. But again, you can write it in anything you want. Then you would have a gateway endpoint that exposes the API that the user interacts with through the user interface. Again, you can use services such as Amazon API Gateway to give a secure and controllable boundary between the endpoint and the backend and the front end. Then you would have some sort of service that sits in the back of the API and where the requests are routed to. And this is where your application logic would reside. So this, of course, can be hosted on any kind of compute instance, but it can also be hosted in what we like to call serverless functions or AWS Lambda, right? And because we're talking about a generative AI application, of course, a lot of this logic will involve forwarding the request to the large language model. And you're seeing this here, right? So the flow of the request would be something like this. The user writes a prompt in the front end, in the UI application. The prompt request gets routed to the Amazon API Gateway. This then gets forwarded to the Lambda function and hits the generative AI model. So far, so good, right? So very straightforward. And of course, the generative AI model looks at the prompt, generates a response, and boom, that gets sent back to the user as the completion for the questionnaire, right? Now, what happens if your generative AI model was what happens if your user has weird intentions, right? They might want to generate text that talks dirty, or they might want to generate racist text, or there could be a lot of scenarios where the user has malicious intent, right? The one thing you could do is use a search service such as Amazon Comprehend to have a comprehension layer on top of whatever you get from the user, even before hitting the generative AI endpoint, right? So you could use this to detect inappropriate prompt responses. So then again, if the user suddenly turns rogue and it sends a nasty prompt to the generative AI model, this can be intercepted in the logic of the Lambda function, sent to Amazon Comprehend, which will then say, oh, no, this will not fly. We can't really hit our endpoint with that. So then the request is actually rejected, and the user gets a message that, yeah, sorry, your prompt is not going to be sent to the generative AI model. And you can also do this the other way around, where maybe the prompt goes through because it was nice and nothing happened. But, models do hallucinate. So the prompt gets through Comprehend, which says, okay, yeah, this looks good. Let's let it across. But then the generative AI model, for some reason, returns some foul language as well. Another thing you could use is Amazon recognition. And this is more for image and content moderation, right? So again, this can be used in a very, very similar fashion, where the prompt gets passed from the user through this whole pipeline, through the user interface, like API gateway, the Lambda function, that again, you can still have the text comprehension in place, and that passes just right. And if the generative AI model returns something that looks extremely uncomfortable and not safe for work, Amazon recognition can catch it and again say, yeah, don't send this to the user because they're going to be offended. So it's easy to add or inject other AI services in the process to safeguard against this kind of weird behavior from either the generative AI models themselves or from malicious users. And if you want to dive deeper into the topic, we do have a blog post available exactly on the topic of this content moderation. I will share the slide afterwards, so you will get them. So no need to scan the QR code now. But just so you know, there's something you can dive deeper into. And here you can see a screenshot of what this might look like, right? If you write, for example, prompt something like a sexy lady, but yeah, you don't really want your model to generate explicitly sexual images of women, then you can put a safeguard in place, and what the user will get is just a message saying, yeah, sorry, the generated image contains unsafe content, we're not going to show it. And of course, there's other things you can do to safeguard against toxicity. So one of the things you can do is to use models that have been trained with responsible use in mind, right? So the data that you put into the model is just as important as the parameters and the design of the neural network behind it, right? It's maybe even more important. And some models have been built with the idea of reducing harmful or inappropriate content in mind. And one such model is the one provided by Amazon, Titan. But there are other third-party models as well that have this benefit. So it's worth looking at the model you're using as well to minimize the risk of foul language and toxicity. Next on the list, we have hallucination. So as I mentioned, when a large language model doesn't really know the source of truth or doesn't have the actual information, it will start spitting out weird things and things that are not really real. So that's why you kind of need to add a cheat sheet to large language models, right? So give them a ability to refer to some sort of truth. And that can be anything. It can be documents that you just store in an S3 bucket. And then in that case, what you would do is you'd have the large language model that just fetch those documents. But especially if you have like a very big corpus of data, you'd want to use a specialized engine or database to store all the documentation, right? So first off, you would, of course, collect your corpus, split up the documents into fragments, and then do some sort of indexing in order to easily search the documents themselves. And then you might ask, what database can you use for this? So there's a lot of them that you can make use of, everything from in-memory databases that you can just run on an instance. So FIS is, for example, a very good library for that. So you can just test the idea of a vector embedding cloud, but it can be more specialized more specialized databases that have been out in the wild for a while, right? So everything from OpenSearch, even RDS with a PostgreSQL extension to support vectors, Elasticache for Redis, Amazon Kindra. There's a lot of services, and the list of products for vector embeddings is growing, ever growing now that generative AI is a thing. And going back to our reference architecture, you can use the search engine or database exactly as you would use the other AI services that I mentioned for content moderation, right? So again, if a user has a query and that one passes through and it hits the Lambda function can do information retrieval on the search engine or database, and then the database will return the most relevant document snippets back. And then what gets passed to the generative AI model is actually a combination of the query from the user, the results from the search engine or database. And also you might have some engineered prompt in place to sanitize the data or instruct the large language model on how the response should look like. And then, of course, based on that, all that information, the user will get some human readable result out of the generative AI model at the end. And this is actually called retrieval augmented generation. So the flow you've seen in there, it's quite well documented. There's a whole research paper in it that you can just read if you want by scanning this QR code. But in essence, it's exactly what I went through. So you build a document index that you search, and then you send the query from the human together with the results of the query to the large language model, and then the response you get will be natural language with the sources for the information, and the generative AI model will know what to generate based on that, right? So again, if you want to deep dive into it, you have the paper here. And of course, there's other sample notebooks that go into this in more detail. So again, just use this QR code to dive deeper into it. And even more if you want to see other databases in the wild, like OpenSearch or Amazon Kendra. There's even more examples. So as you can see, I'm putting in a lot of references, and you can dive deeper if you so want to. And another thing to mention is that Amazon Bedrock, so the high-level service that I talked about, it has built-in support for retrieval augmentation. So you actually have a UI where you can specify the knowledge base sources, and then Amazon Bedrock will try to connect all the dots in between in order to make sure that your large language model fetches the correct information for you. And you can see here on the side that it supports a lot of databases out of the box, and more are also coming soon. So again, something to look at. And last but not least, let's talk a bit about building artificial intelligence agents with tools, right? So again, what these tools could provide could be anything from access to the internet or the capability to do mathematical calculation, like really advanced ones. And it's basically anything you can think of. So in order to get a bit into that, we need a refresher on prompt engineering. Of course, prompt engineering allows you to interact with a model in real time, and it's a way to influence the output of the model. So of course, you can ask the question that you want the model to answer, but you can also instruct it on the behavior that you want to get out of it. And standard prompting gets you a long way, but sometimes it's also not enough. So for example, if you want to do basic math, you're seeing this example here, right? We have Roger, he has 5 tennis balls, he buys 2 more and 2 more cans, and each can has 3. So how many balls does he have now? And the bot answers that the answer is 11, which is actually correct, right? So in this case, it got it right. But then we have another example with 23 apples, and it's kind of the same reasoning behind the question, like in the first question with Roger, right? But in this case, the model outputs that the answer is 27. Because again, the model does not really understand mathematical principles. It sort of looks at what is statistically correct as the next word to put in there, which means that if the model has seen this challenge around Roger before, it will most likely respond correctly. But if you change the numbers, or you come up with a different scenario that looks exactly the same, but if it's with a cafeteria, the model might not really get it right, as it happens here. So apparently, one thing that really makes prompting better is what we call chain of thought prompting. So this is where you give the model you give it a one-shot example of how it can reason about a thing in separate steps. So again, we have this challenge from Roger, who has the 5 tennis balls, but then we also provide the model with an example here, where we say that Roger started with 5 balls, 2 cans of 3 tennis balls, and each is 6 tennis balls. So we split the logic, right? We try to show the model that it needs to think in baby steps in order to get to the correct answer. And if we do that, you'll suddenly see that the model will try to replicate this chain of thought reasoning, and it will get to the correct result. Not every time, again, but a lot more often than in the standard prompting technique. And again, this is quite a research topic. So there is a chain of thought prompting paper out there that talks more about these findings on how it actually pushes the large language model to reason. So if you want to read about it, you can again scan this QR code and dive deeper into it. And besides that, so chain of thought reasoning is great. But if you want to combine it with agents or give the model the ability to go out there and use a tool basically to enrich its knowledge of the world, you also have to use some other methodology. And this one is called ReAct, right? Or this paper actually looks into combining the chain of thought reasoning with acting on the question from the user. So again, it is an extension to the chain of thought prompting concept that I just showed you. And what it does is that it adds a set of predefined actions to the LLM that it can choose from. So it can be anything like, oh, so if the user asks about a history question, try looking it up on Wikipedia. Or if the prompt for the user has numbers, try to put it in this calculator system that you have access to, right? And then once you add this predefined set of actions, you ask the model to sort of break it down into tasks in a loop, right? Where you have the question, the thought, the action, and the observation, and that loop is repeated until the model gets to the final answer. So a lot of theory, but let's look at an example because this will make it even more clear, right? So let's say you have this question. How many rooms are in the hotel that is home to the Cirque du Soleil show Mystère? Okay. So then what would happen in React is the model gets the question and then it starts generating thoughts, right? So the thought one would be, I need to search Cirque du Soleil show Mystère, find the hotel it is in, and then find the number of rooms in the hotel. So the action here is to do a search operation. And again, the search operation is actually the model searching with an agent somewhere. It can be the internet, it can be Wikipedia, it can be something else, whatever you define it to be, and that will be defined in code. It will just be a code tool that the model uses to access the information. And then, yeah, in this case, the observation is that it could not find Cirque du Soleil. So then it only found like similar articles, right? So then the model generates a second thought. To find the hotel, I can also search for Mystère Cirque du Soleil. So it tries different basically inputs for the search service. And then this time it gets a response back, right? And in this case, it's exactly the description of the Mystère show, where it is held, and so on and so forth. So then the third thought of the model will be, I read the observation, so there's a lot of information in there. So this is what I found out. Mystère is held in a custom theater at the Treasure Island Hotel and Casino. So now I need to search for this specific location next and find the number of rooms in the hotel. So again, you can see how basically the model goes down the rabbit hole, pretty much like with what we're doing when we're searching the internet, right? We start with one thing and then we go deeper and deeper and we find the response to that. And again, so it searches for the hotel and casino, Treasure Island, and it gets the information from the internet, or again, whatever other source of information it's using, that it has, there's a full description, right? With the hotel and the hotel rooms and suites, blah, blah, blah. And then the final thought will be that, okay, so I got this response and looking at observation number 3, Treasure Island and Casino has that many rooms and suites. So then the model can conclude that it has actually finished. And this is the final response. So the loop of thought, action, observation can finish, and the response can be returned to the user. So as you can see, React is actually a very, very powerful mechanism because it looks very, very similar to human thinking. And it gives the large language model the possibility to think about specific actions with intent, which is quite amazing. And the good part is that if you wrap your head around retrieval augmented generation and also filtering and everything that I mentioned today, implementing this React framework is quite similar, right? So we're still looking at the same application infrastructure where we have the UI gateway, the backend with the logic and the generative AI model. But this time, what we're doing is that we're actually embedding the React logic within the Lambda function or the application logic itself. And you can easily do that with LangChain. So LangChain is a machine learning, or rather, I would call it an LLM ops framework that gives you access to a lot of these prompting chains and techniques out of the box. So chain of thought reasoning, but also React is available in LangChain out of the box so that you don't have to implement it yourself. Of course, you could also read the paper and build your own flavor of React, but why reinvent the wheel when it's already available, right? And then, of course, we have any other service, because as I said, React can be used with any kind of tool. So this could be anything like a SQL driver, a tool to search the internet, Wikipedia, a calculator, you can think of pretty much anything that you can put in code, and that can be a tool, right? And then how it happens is that the user, again, provides the prompt, it goes through the whole flow, it hits the Lambda function, and it provides the prompt completion to the generative AI model. That one sort of starts the React process, right? Because as you've seen, the React logic actually is a loop, right? So that's why you're seeing so much back and forth between the Lambda function and the generative AI model, and also the third-party service, right? Because if you go back to the Cirque du Soleil example, you've seen that the model had to go through like three to four. Yeah, no, it ended on the fourth. So it had to go through 3 loops to actually get the final response. And these loops included going through the whole chain of thought, accessing the service, analyzing the response, and doing that again a couple of times until it was happy with the response, right? And then, of course, once that happens, the completion gets passed back. So again, the same architecture, same pattern. It's just that we are ingesting different things to help with the application logic in the serverless compute layer, right? And we are injecting also other helper services to help us. It could either be other AI services, or it could be databases, or it could be any other code written with a specific purpose, as long as the generative AI model understands what it can use it for. And no surprise here, but Amazon Bedrock also has React built in. We actually call it agents in Bedrock. And you can use these agents to easily create this sort of actions and tools to allow you to fetch your information from other sources. And again, I will leave the link here, and you will get the slides after the presentation if you want to dive deeper into it. But yeah, this is basically everything I had to say. So I think we will have a break, and then it will be lab time. Before we move on, though, I wanted to mention that there's even more resources at the end of the presentation. There's again a lot on LangChain, because I mentioned it, Streamlit, which is a tool for user interface prototyping. There's Mozilla hack blogs that you can look at if you want to build your own open source chatbot, prompting guide, learn to prompt. Again, a lot of resources, and you can check all of them if you want to stay up to date with information. And then, if you want to really dive deep into generative AI with large language models, there's actually a 3-week course on Coursera that has been developed between AWS and deeplearning.ai, and you can check it out. For the most part, it's free. You only have to pay if you want to run the labs as well, because those need, of course, compute resources. But if you just want to go through the theory and the courses and understand everything better, because to be honest, one hour is not necessarily enough to really understand large language models, you can go and check out the course, right? And then another tip is that you can look also on YouTube. We have a Generative AI Foundations course, which is completely free. And again, 7 chapters, 8 hours. You can also dive deep into the concepts with this one. So it's kind of like you pick your own adventure and you dive deeper into whatever you want to see. And with that, I leave you to it. I also left my contact details here if you want to talk about things more on LinkedIn or by email. And I'm opening the floor for questions. I haven't actually checked how much time we have, but I think we still have 4 minutes, something like that. So any questions?
We have enough time. I can check our Q&A session, but I think all questions are answered already. So we don't have actually questions. I like very much you have emojis in your presentation. And it was very easy to follow. Thank you. Thank you very much. So Miguel, do we have already this link I put for workshop for our labs?
Yes. Should we post it again here?
We can post it also in our chat, and I can stop recording for this time. So after 5 minutes break, we have labs, and we decided we stay in our main room for these labs. Yeah. Thank you.
Yes, meet you in 5 minutes.
Thank you.
And thank you, Ana Maria, for the presentation and for joining
Yeah.
so early. Ana Maria is
My
in the
pleasure.
US.
Yeah, you
So
said
it is,
morning time.
yeah.
Yes.
Yeah. Thank you.
Exactly.
Yeah.
Thank
Thank you very
Thank
much.
you.
Bye.
Bye.
Bye-bye. Okay, so it's 2:15 and we can start with the lab. Anna has already started recording as well. Right, so you've heard about large language models, some of our services already. We are not going to introduce a lot of new stuff here. It's basically going to be hands-on so that you get a better feeling for the topics we were talking about. And hopefully you can see my screen, right?
Yeah, we can see.
All right, so what are we going to learn? So there is a lot of things going on today. So we are going to host a large language model. What that means, we're going to create an endpoint, an API that we can invoke a model of our choice. In this case, it will be Llama 2 on SageMaker. So this is not going to be a SaaS service like you're used to use, OpenAI or Bedrock. It's going to be your own running model. After that, we will build a small playground, kind of a UI, simple UI based on Streamlit, a very nice application for building data-based applications so that we can easily interact with that model. And it's quite fun to chat with it, you will see. Then we'll talk about two other AWS services beyond SageMaker, which some of you might not yet be familiar with. One is DynamoDB. DynamoDB is a key value store. It's like a database where you put a key, and then for that key, you store any type of value. Can be structured, unstructured. To retrieve that back, you just provide the key. That's how it works. And then we have Kendra. Amazon Kendra is going to be our document index. So this is a service, again, that can index, for example, all of your company's documents, or can crawl the web even and create an index of different types of content. Finally, we will build a RAG-based application. So you by now should be a little bit familiar what RAG is, but it will become more concrete using LangChain. So let's first talk about one thing that we might not have touched yet on, which is Hugging Face. Hugging Face is like GitHub for large language models. It's like, in GitHub you find open source code. In Hugging Face you find open source natural language models. And you find the base models like Llama 2, but you also find many fine-tuned versions that users have published. For example, in the beginning, Marco mentioned the Bloomberg GPT, which is a fine-tuned version of the GPT model for financial data. So people are publishing models there, and some of them get really popular. And that's where we're going to take Llama 2 from. So AWS SageMaker has a very deep integration with Hugging Face that makes it very easy for you to pick any model from that hub and run it on AWS for yourself. Nobody else can access that. And we will see how easy that is done. Quickly on Llama 2. So this is one of the most performing, like based on these external benchmarks, this is one of the best performing open source model. In some cases, it's at the same level as some of the closed source like Claude, ChatGPT. So Llama 2 performs very well. It was released by Meta. It is available for commercial use, meaning if you want to build your commercial application on top of this model, you can do that. It has a 4,000 token context length. That's the amount of data you can send, the amount of text, actually tokens, that you can send to it for it to kind of predict the next word and the next word and so on. It has 3 model sizes, so you can deploy a smaller version that is cheaper because the model itself is smaller, you don't need as large of an instance to host it. You don't need as much memory, GPU memory. But then you have the middle size and you have the larger size. The advantages of the smaller size beyond the cost of hosting is also the speed. Since these are smaller models, when you send a request with text, it will be faster to process that request as well. We're going to use that 7 billion and you will see how good it is, even the smallest one. Of course, the biggest, the 70 billion parameter one should be the one offering the most quality. Another thing I want to, so this is all in preparation of the workshop, right? So when we deploy the model, what we are doing is that SageMaker will bootstrap an instance running your model in a container that is Hugging Face provided, as well as the model is also Hugging Face provided, but it is brought into the AWS into these instances that are managed by SageMaker, and they can even be, you can even deploy multiple if you want to auto scale, if there is a lot of requests coming to your model, or in different availability zones, meaning for high availability, basically if one region of or one data center in AWS goes down, your model is still running in the other data center. So all this stuff you see here is going to be put up by you by a simple SageMaker call. And you'll then be able to call the model doing an HTTP request. Right. So how much it costs? So this is not the same pricing model as you're used to with ChatGPT or others, where it's a SaaS service. You just send requests and it's based on the tokens. How many tokens you process, you are charged an amount. Here it's for running time because we are hosting it in your own infrastructure in an endpoint. You will pay for the ones that we will provision, the Llama 7B at the bottom here. It costs about $36 per day to host. So this is something to take into account as well. The largest models in our largest hosting instance in SageMaker, it would cost about $500 a day. So we are going to send data to the model. The model will reply with the next word. One thing to understand is that actually these models don't have memory. We can add memory to the conversation by using, we will use actually DynamoDB or just in-memory, like as you run your application, you just store the conversation and send it back into the context of the model. So basically what the model does is you send it a sentence and it predicts the next word. If you then append that next word into that context, and it will give you the next word and the next and so on. So it's called an autoregressive because it generates one token at a time. SageMaker offers a feature because if you are doing a UI, it's nice if the model is responding fast, right? If you want it to generate a recipe for omelets, and that recipe is consisting of 300 words, if you need to wait for the model to generate all these 300 words, it might take maybe, I don't know, 1 or 2 seconds. Well, it's not much still. It is a latency. So if you can get the words as they are generated one by one into the UI, that is much nicer user experience. And SageMaker offers that possibility to stream the tokens as they are generated into the user. We will not be using this in the workshop today, but it is very simple to implement as well. Now, Streamlit we will use. Streamlit is that Python-based data application building framework. You will see how simple it is, like the code that we use here for interacting with the model. So instead of running it in the Jupyter notebook that you send a text, a string, a prompt, and then you get the response back, we are going to do that in a UI. It's much nicer. And then you can add features like drop downs where you choose the language or you choose the style that the bot should respond in. You can also do visualizations of plots and things. We are not going to use that feature there, but Streamlit is pretty easy and powerful. And the next one is LangChain. So this is another thing I want just to make sure everybody understands that models themselves, they are just functions. Like I showed you that autoregressive, they get an input, they give you an output. Now they are not able to run code. The model itself is not able. So you need something that kind of runs code if you want to, like to create like a React reason and act type of workloads where you have agents scrolling the web or running lambdas. or using a calculator. So you need to kind of send the prompt to the model, get your response, and then check the response if you need to do an action, and then that action itself is run by your application. And that application, coordinating all these can be done with LangChain. So LangChain is just providing you the abstractions that you will anyway start to work once you start developing applications with large language models. These are the abstractions that will be useful. So it's a nice starting point, not to create everything from scratch. So it helps you connect to the model itself, to the memory, which can be DynamoDB or can be in-host memory, connect to document stores, to vector databases, to Lambda functions, and so on. And then Kendra, we already discussed. So to simplify the whole kind of RAG approach, so retrieval augmented generation, where you kind of give context to the model for it to be able to extract questions from current data, because as you know, these models were trained with data that is outdated, so they don't know about current events, they don't know what time it is, they don't know what's the weather like today. But if you give them access to the outside world, for example, to a Kendra index that contains your knowledge updated data base of data, you can then use that in the prompt. So you can fetch the most relevant parts that are useful to answer the question you have, feed it into that prompt, and then the model will use that external information to provide you the answer. So this is how a retrieval augmented generation workflow would look like. So all orchestrated by LangChain. So we're gonna do this in the lab. So Kendra is gonna index a bunch of PDF documents that we will download. It will be about company annual reports for Amazon, Meta, and Tesla. But you could download any other types of documents. You can adapt this workshop very easily. Kendra is gonna index those PDFs and present it as part of its search API. So when I have a question, the one thing it will do is like this question semantically, like the meaning of the question I'm trying to ask, what is the closest document semantically to this question? And I'll retrieve that document, a snippet, actually not the whole document, because again, these models have a context, they have a limited context. So it will actually look at the fragment. So Kendra will cut these documents into fragments, will present the most relevant fragment for the question, and then that is used to answer the question itself. So this is what we will be building. So we are the user here. We're gonna run again in SageMaker Studio for those who have been in our previous workshops. You already know how Studio works more or less. It's a hosted Jupyter Lab environment. So we will run a Jupyter notebook in SageMaker Studio that I have prepared. We'll create a Streamlit UI that is using LangChain to orchestrate these different components, these three components on the right. So we have the SageMaker endpoint where our Llama 2 model is hosted. So that's how we can call the model when we need. Then we have the Amazon DynamoDB table where we will store the conversations we are having with the model. So that's useful because as I ask the next question, I don't need to keep phrasing. Like if I say, what is Amazon's total revenue for this quarter, it will answer. And if I then ask, what was its revenue last quarter? I don't need to specify it's Amazon I'm talking about because I'm adding memory to that prompt. So I'm appending that history, that chat history to the prompt itself. And finally, we have Kendra where we will retrieve these fragments of the documents that we want to use for answering our questions. So starting, I've already pasted the link on the, some of you I've seen have already accessed the event. If you haven't, please find the link in the chat, click on it, and you will, so with that link, you won't even need to enter the code as I'm showing here. you will just be taken directly to this. So on the top left here. So you will need to sign in with your email. It's very simple. Just click on email me, one OTP, then provide your email. Then it will send you an OTP. You have to wait a few seconds for the email to arrive, and then add that email, add that one-time password in the next screen. Then there will be a accept terms and conditions that you need to check the checkbox, and then join event. And let me know if you have any trouble with this part before I continue to the next part. So this is just to access the AWS. So this will be used then to access our AWS account where you will be running the lab. So we are not going to do the labs that are there. So I see some people already joined to the, or are already checking the content. So please ignore the content part on the workshop. The one thing you will need to do when you get there is this. So you will need to, so there is content here, lab 1, lab 2, lab 3. We're actually going to do a version of lab 4. So this workshop was designed for 6 hours. We don't have 6 hours. So I created a version, a simplified and more straight to the point version of basically lab. Well, sorry, this screen is showing a complete wrong workshop. But what you have there is 4 labs. We're going to do a version of lab 4, but it's my own notebook that you will download, and you will see the instructions inside of the Jupyter notebook. So the only thing you need to do is click here when you get to this screen. On the bottom left, there is Open AWS Console. And then you will go to the SageMaker. So you either find it immediately when you log into the console, or you need to search at the top. On the top, there is services, and then there is like a search box. Just start typing SageMaker, it will show up. And within SageMaker, you can either go to domains, or actually, I think Studio might even be a better. So when you are in the SageMaker console, so this bottom screenshot here in this slide, click on Studio, or just follow this. It's easier, maybe the screenshot. So click on domains, and then click on your domain. I'm not showing that here, but there is a workshop or something named Studio Domain. So that's the ID that is hosted. Click on it,
In
and
my
then
case, it's my domain. And
my
then
domain,
when,
yes.
when click, it will be SageMaker user. So should we select this studio?
Studio, exactly,
from
the
launch.
first one.
Okay, yeah.
Yeah, there is many layers here to get started, because we're using a workshop kind of management service to log into AWS account, to log into Studio, to get to our notebook. That's why we have all these layers. But in practice, if you would have an AWS account, or you'd be working in a company with AWS access, your SSO could have a direct login to SageMaker Studio. So when you start working with SageMaker, you just log into your company, SSO, and click SageMaker Studio, and you go straight to to that interface. And this is when you are in SageMaker Studio already. And let me know if you are falling behind. But in SageMaker Studio, what the first thing you will do is download the lab that we are going to run. So open a terminal within Studio, so not your own laptop terminal or desktop terminal, but within the Studio environment, you can also open a terminal to run some bash commands. And there we will do this. So I'm gonna paste this part. I'm gonna paste this part, or
yeah, I was just gonna ask that. Do you paste it?
yeah. Just now that I'm presenting, it's gonna. Let me see. Can you mark if you have that at hand? I'm also trying to find it, but if you can.
Copy and paste the instructions.
The commands, the instructions, yeah. So the cd, the curl command, and the tar.
Yes,
so
1 second.
Yeah.
Copy and paste it to the chat, correct?
I have pasted
Thank you.
in the Q&A session now.
Thank you. So it's in the open Q&A. Yes. So if you copy paste that, great. Inside the terminal, you paste it inside the terminal. It should then, so first you should have a folder only there. When you do this, run these commands, you will get a notebook called RAG with Llama 2. So that Jupyter notebook is what we want to open to start running the lab.
Can you repeat that? What the command does? So basically,
yeah. So this command will get from, well, I'm just hosting it in a, like a place to host like artifacts or whatever code, and I'm just copying it, like doing a curl command to copy it locally to the Studio environment. So it will show up in your local file system. So if you go to the folder icon on the left of SageMaker Studio, you will see that show up, that tarred file, and then you untar it, you unpack it. So then inside of it, there will be a folder with images that are used within the notebook, and there will be the notebook file and with IPyNB extension, and there will be two other files, which is the Streamlit app and the LangChain app that I pre-created. So they will be there as well. I can show you how it looks. So it will look something like this if you've done everything right. And you need to open that RAG with Llama 2 IPyNB.
For me, it says an invalid option for the tar.
So there is a problem with the pasting of the.
Yeah.
I had the same. So please delete the dash and type the dash. I think it's just a copying of the dash between different fonts.
Okay.
To the terminal somehow corrupts that character. So just, yeah.
Got it.
Cool. What about others? Nobody's complaining?
Which was the format for the last command? Because I still get this invalid option message.
So same,
thank you.
Yeah, so the same thing. So if you delete, so the tar minus xzf, just delete that dash, that minus, and type it again in that terminal. It's just a problem with the copy pasting. I had the same. I don't know how to fix that when pasting it Somehow that dash gets always corrupted. But only that one for some reason, not the other dashes in the...
That's so funny.
Yeah, I don't understand. Did that fix you, Tanya? Was it Tanya?
Not yet, sorry, maybe I just didn't get which I needed to correct, so sorry for the delay.
No worries at all. So let me maybe paste this again here so to explain what I mean. So when you are so there are three commands. There is cd, there is the curl, and then there is tar command, this last command. This is the one that is failing. So what you need to do is you delete that from xzf, you delete that dash on the terminal itself. Maybe I can show actually. Let me see if I can show it. Is it easier? Takes a while to change the screen. I'll share. So we are in the terminal, and there is this command here. What you need to do is you need to go remove this dash. Do you see it's a bit longer dash? For some reason it gets pasted like that. So that's the invalid character you get there. You get this error, right? So you delete it and just type it, and then it works. Did that help?
Yes, thank you so much.
Cool. And let me go maybe back to the, so yeah, maybe I can continue here, why not? So once you are, so I'm doing the same steps as you, right? So once you have unpacked the files, you just open this one, double click, and you will be taken to the notebook itself, and you will be asked like what environment to run this notebook on. So what image with pre-included libraries are you going to use? So we're going to choose data science 3. So that includes the most common Python packages that we will be using. And then the instance type is like for running the notebook, you need some kind of compute, right? And this is the compute. And we choose here the small or the default one, which is T3 medium. It's quite a small and inexpensive instance because we're not going to do anything heavy on the notebook itself. And then you say select, and it takes a few seconds, or in my case, I already had an instance. So it was pretty quick. In your case, it might take a few moments. You have a spinning wheel there at the top until that compute for this notebook is provisioned. So let's see how far we can get today. I kind of divided it in two parts. So first, let me see. Okay, are you all familiar with Jupyter Notebooks, how you run a notebook? So you can click, so the notebook is consists of many cells. So here is one cell. If I go down, there is another cell. There is another cell. Some cells are just documentation. Other cells are code. If I run a code cell, that code will execute. And by running, I mean clicking here, or another way is Shift Enter. So if you click Shift Enter from your keyboard, it will also run that cell where that you are highlighting at that moment. And you can go back and forth, run the cells again. So this is how notebooks work. And yes, the first thing we do here is upgrade some of the installed packages within the notebook. And if you see warnings like this, don't worry. If the notebook has a number, if the cell has a number, it means it ran successfully. So these warnings are just Python related, package related things that we were not able to fix before the lab, but it's nothing to worry about. Yeah, so this is divided in two parts. So the first one, we will deploy the model, and we will start running it with LangChain. So we're going to make invocations without anything else, no memory, no document store. We're just going to see how the model responds to our queries using LangChain to call the model, to call the SageMaker endpoint. That's the first part. So we go, the first part ends, we continue to scroll down. We still add memory actually, but we're going to use just a memory that does not require any external service. It's just going to live in the application, that memory. Then we'll do a conversation. Okay, then we will use DynamoDB for storing the conversation for future access. If you might want to get back to a conversation. So we start using DynamoDB here and show how easy it is to integrate DynamoDB memory when you are using LangChain. There is native integration to DynamoDB. But yeah, so after that, we continue going down. And this is the second part. So if we already finished the first part, I'm happy. But the goal would be to finish the second part, which is the real interesting one as well. And there we are going to use Kendra as well. We're going to add Kendra. And basically, yeah, we're just adding Kendra, but then also changing the LangChain application to work with Kendra to answer the questions. Okay, but let's back to the start. Please start running the cells in order. So start at the top. Try to understand. You can change the code when it makes sense. So if you, when you get to here, for example, let me, like here, want to hear a joke. You can change this to anything. This is when we are prompting the model. You can change this to anything, just to see how it responds. So have fun with it. Try to be creative and explore. Don't stay limited to the code that is here. Try to understand the code and then try to do some small changes. Also, the parameters of the model, these are kind of default. You can also play with those if you are interested. So the temperature, meaning how creative that response will be and things like that. Right, there is one here that I have a warning in the notebook. I just want to make you aware that this will take about 5 minutes. This is the deployment part. This is the time that takes a bit longer, that you will need to wait a bit. You can stretch your legs or something during that time. Why? Because we need to fetch the model from Hugging Face, bring up the infrastructure, the G5 2x large, which has a NVIDIA GPU. So it needs to boot up, bring the container that will host the model, bring the model, the Llama 2 model into the container, and then start the web server and start serving requests to your that you can then use it. So that's why this will take a while, because it's not a a hosted model like we would like to have used Bedrock here, right? Because with Bedrock you don't need to do any of this. It's a pay-as-you-go type of service. However, the Bedrock is still not enabled in these accounts, in this workshop account. So we need to deploy first the model ourselves. But I think it's a useful exercise to see first how easy it is. And also because with this type of code, you can deploy any model out there that is open source, basically. So you don't need to limit yourself to the models that exist right now in Bedrock or in OpenAI.
Yeah, that's a good call, Miguel. And can I ask about the so now we're running the Jupyter notebook, and that's usually for for workshops or if you're doing research or trying out stuff. But as I can see that there is a Python like a like just not a notebook but Python files as well. So those are kind of the finished versions, right, of this whole exercise.
Yes, so I didn't. So of course, because you could have built, and you can build and change these. So I just provided like, and these applications, we are going to run them inside of Studio. So Studio, yeah, but you are right that these are the application code that should run, for example, in a Docker container, in ECS, or anywhere you would host an application, in Lambda, like Ana Maria was explaining. So that's the actual code. So there is two parts. There is the front end, which is the Streamlit. This would be front end code. So as you see, quite simple. That's all. That's it. For the UI, this is all you need. And then there is the app the backend, which is LangChain, which does this interfacing with the model, with Kendra, with DynamoDB, and so on. And again, not very complex. You see how small, how few code I have here. Some of this code is repeated from the notebook, because in the notebook we are also running LangChain, right, to show you how LangChain works. But then we put it in the file just to run it as an application.
Yes, that's a good clarification.
Yeah, thank you for highlighting that as well.
No, it's just I'm a data scientist myself, and I'm more on the kind of coming from the analytics background, so notebooks are more familiar to me. And then all these applications are or have been like less familiar, and then I'm getting confused, like where should I run stuff? And then notebooks are great for investigating and like documenting and stuff like that. But then when you actually want to run and deploy stuff, then you don't want to have that one. So
I recommend you to have a look at Streamlit, like for if you are running a lot of these data related things. It's really easy, especially because you already know Python. So it's very easy. You can run it in your laptop, right? So that's what I'm doing when I'm experimenting and not using Studio. I just install Streamlit with pip install, and then I create the Streamlit application and run it, and then it opens the browser localhost, you see. Then you have that. So it's something to have a look at. Might be useful for your work. So maybe I'll now shut up a bit and let you work on the lab, and please ask questions, and I can jump in to clarify any parts of the lab a bit later. Okay, so when you deploy the endpoint, so there is that cell here. So more up here. So at some point the cell finishes and you have an endpoint, and your endpoint name, I'm saving it to a variable here, endpoint. If you create a cell under, for example, and just print this is the actual endpoint name. This is what you have to copy and paste into the LangChain app. So here in endpoint, you need to paste this. Does that help? Another way to check the deployed endpoints in Studio is to go home on the left, deployments, and then endpoints, and you should see all the deployed models that you have. So this one was created 15 minutes ago, and this is the name, so you can copy the name from here as well. Just right-click, copy. So this is individual for each, it appends a timestamp. So it's a unique name for each model that you deploy. And so, but that's already when you run the Streamlit and LangChain. But before that, we do some LangChain magic here in the notebook. And what we do is we create the simplest chain. So LangChain has this concept of chains, which is sequence of actions in your application. And the simplest of them is just the LLM chain, which just calls the large language model, prompts the model, and retrieves the response. That's the simplest chain. And we are going to, so it integrates directly with SageMaker endpoint. So there is a class in LangChain for SageMaker endpoint. You give the endpoint name here, it's stored in the variable. A content handler so that it knows what to do when it sends the payload to the endpoint and retrieves the payload. How does it have to encode it and decode it? And this is what we defined here before. So it's a JSON encoding and decoding. So we send the JSON encoded into a byte stream. As you know, the HTTP requests are bytes. And then when we get back bytes that we decode again into JSON, which is our response. And that's why you can then access fields of the response. In this case, the LangChain just, if you just call that SageMaker endpoint with the prompt, and it just returns the response. Great, Emmy. I hope you can play around with Llama. It's yeah, try different things and different prompts. So I also wanted to explain these prompt templates. There is a bit of a funny code here. Okay, so you see these characters here. So as you probably know, the models themselves, they are functions, but they work not with words, they work with tokens, right? And actually, when you invoke these models, most of the time, you're not sending the tokens yourself. The serving, the containers that host these models, they make that easy for you. So do all the transformation on the input data needed to feed the final result into the model. And then the same thing on the way back, they transform the return tokens back into words that you can use in your application. This serving container from Hugging Face, this version of it does not yet have that. Well, it does have the token part, but you still need to send it. So this is an instruction fine-tuned model, meaning that it follows instructions. It's not the base pre-trained model. It's already fine-tuned for following instructions. And the way it was fine-tuned is to look for the special token, start of sentence, inst, which means an instruction is coming, sys, which means that there is a way you want the model to behave. It's like a system prompt. So this all has been used in the training data itself, so that now when I use the model, it learns how to react to those. It has seen these tokens and it knows what to do when it sees these tokens. Just a second. Yes, so exactly. So this is what I was explaining. And here I'm also building a prompt. So LangChain also includes prompt templates and commonly used prompts. Here I'm building my own Llama 2 prompt because Llama 2 was quite new when I started using it. And I don't believe LangChain still had this, structuring of the prompt into this shape. So I just do my own kind of prompt template. So here in the prompt template, I have chat history. So I'm going to go through a chat history variable that where I will be storing all my chat with the model. So I'm going to extend the initial chain, which was just calling the model, with a memory. And the way to do it is very simple. It just say that I have a prompt template and I have memory, and it will be stored in the memory key, which is a variable in Python called chat history. And I'm going to keep the last 3 messages. So that's the history I'm going to use. Of course, if you use a too long history, it might be that it doesn't fit in the model. So it's kind of a sliding window over your conversation. You can try out different values here as well. And what you will see that when you append memory is that you can now talk with the model, no longer just prompt it. I need to run a few cells before that. So it's no longer just prompting the model. You can now chat with it because it remembers what you previously said. So now if I ask it, hey, how do I bake an omelet? And actually what you see here in green showing up, it's the LangChain executing the sequence of steps because I put this flag here on verbal. So I create a new chain called LLM chain with memory, and I say verbose true. So I see what is happening behind the scenes. It's just like a logging type of thing. And this is the prompt it's getting. So I'm telling it that you are a helpful AI bot in the system prompt. And then my actual user instruction, hi Llama, how do you bake an omelet? And then this is the result. Oh, it's quite excited because I told it to be an helpful AI bot. If you look at the Streamlit, I also included other like reply only with emojis and things like that. So if I would do that in the system prompt, so I'm gonna go back and say here, please reply in emojis. You are a helpful assistant. Please reply only in emojis. So now if I again run this, look at that. So it's quite funny. So it's showing me some eggs there. But now the good thing is that when I now ask it, could you repeat the recipe, but using the metric system because it gave me ounces and things like that. Well, it remembers my conversation, so it knows what I'm talking about. So because now what he gets as a prompt is this. It's all this that you see here in green. It's the initial, so it's the system prompt, you are a helpful assistant, reply in emojis, followed by the first conversation, the first question, hi Llama, how do you bake an omelet? And then with the tag saying that this is the end of my instruction. Then there is the assistant part, which is the emojis you see there. And then again, another instruction, which is the second question. Could you repeat the same, but using the metric system? Now, this is the whole thing that the model is getting now. And as said, it is trained to understand conversations. So it understands that this is the user, this is the AI, this is the user, and now it's expecting to, again, act as the AI responding to the user. So we have now memory, but it's not being stored. So if I shut down SageMaker Studio or this notebook or restart it, it will lose all the conversation because it's stored in memory. So the next thing we are going to do, wow, this is cool. Lots of smileys there. The next thing is that many of you have already done is to add the DynamoDB part. And I don't know if I'm missing questions now, talking so much. So let me check a bit the chat. Feel free also to jump in, and we are not that many, so you can also use audio. Back to the AWS console, and you go to SageMaker. So this is maybe the simplest way. There is no real, from Studio, you can see the endpoints, but you cannot really delete them straight away unless you run some code. So here you go to inference. I'm gonna make it larger. So on the SageMaker, inference, endpoints. Then you will have two endpoints here. Select one and actions, delete. And the same for the second one.
Miguel, can you also show the code snippet that does it from the Jupyter Studio?
So the problem might be that your predictor object that is linked to the endpoint. So you could just call, let me go. Oh yeah, at the end. Okay, this is the simplest way. So if you know the endpoint name, you just create a predictor object pointing at that endpoint name. So replace these with the endpoints you find. So because this variable might no longer have the value that you're trying to delete, the endpoint name value, and just delete model and delete endpoint. That's it. So this should be the name, like Hugging Face, something, something, which is found from here or found from deployment in Studio endpoints. It's also here. We will create that. So for the second part, we are creating the Kendra index. And so just to describe you a bit what is happening here. So this part happens in the AWS console. You create an index and you add a data source to that index. That data source will be S3. So you have an S3 bucket. This is our object storage service. And you will upload a PDF, a collection of PDFs that I just got from the internet. So here is the wget, just downloading these PDFs. And these are Tesla, quarterly, second quarter report, 2023. And then there is NVIDIA, Meta, and Amazon quarterly report. So this is information that the model doesn't have from pre-training data. It never has seen this data. It's new data. We index it with Kendra. So this will go to an S3 bucket. That's what these cells are doing. So I'm downloading them locally first. Then I'm uploading them to a SageMaker default bucket. This is the bucket. It will be different for every account. So I'm syncing these files there to a PDFs kind of subfolder in S3. So this is where they are going to end up in. Oh, it only found one PDF. What is happening? Should have downloaded 3 PDFs. Yeah. And then I should sync these to S3. Maybe because I already had them. And okay, funny. You probably will see like 4 uploads here for your documents to S3. And then you tell the Kendra to crawl your data source. So there is a small animation here showing you how to add this data source. It will also create a role to be able to access that S3 bucket. And yeah, it will take about 5 minutes again, because it needs to crawl the documents and add them to the index. So it will do this chunking of the documents. And what Kendra does in the back is actually it has a vector store. It's kind of like an index, like OpenSearch or anything like that, that you can then access these fragments. And the way it does it is like when you ask a question, it also computes a vector that has meaning about that question and finds the most similar vectors inside of the index and retrieves the top 3 as the context for your question. It's a bit, you need to think a bit around that. It's not like immediately clear. It wasn't for me at least. But once you wrap your head around what is happening here, it becomes quite natural and you can understand the power of this type of approach. Of course, there is many things to say here regarding how do you chunk the documents and how do you compute the similarity between the question. Does the question have enough words to create a meaningful, that it will be able to match the right snippets? So you need to also kind of like, this is not prompt engineering, but kind of make questions that elicit the right documents to be returned. Here we only have 4 documents, so I'm going to ask it questions about Meta and about Amazon. What did I forget to run? Oh, I need an index ID. So to run this cell, again, this is not going to run. Actually, I'm not going to run Kendra on Streamlit. Now I remember how I did this. So the Streamlit is just showing you memory, the prompting, how you build a Streamlit app with LangChain, but not a RAG use case, just a normal LangChain chain, simple one with memory. And the part with the Kendra, I'm just going to run on the notebook. So we could have also copied this code into the LangChain app code and run it there, but we're just, for the time's sake as well, just running it in the notebook. And I'm adding the index ID here. Let me find it. So I've already indexed data, so you can see it from data sources, my S3 PDFs, and it has done, the last sync was yesterday evening, and it found 4 PDFs, 4 documents, so that's good. That's what I expect. And the index itself, the ID for the index, is here, index ID. Copy that and add it to my notebook, and you will have a different value for this, of course. And now if I run it, so now I have a different LangChain chain. Again, LangChain makes it simple for me to do all this workflow of, so I create a question. The question is vectorized. It's going to Kendra to check the relevant documents, getting the snippets of the documents back, adding it to the question, and again, asking the model using this context, these documents, and my question, what is the answer? It is also doing something called condensing the question. So my question actually comes in a history of messages with the bot. So if I'm saying, again, like I explained before, like what is Amazon's revenue on the second quarter? And then if I refer to what is the company's profitability, it knows that I'm talking about Amazon because it has the whole conversation history. So it will summarize this question, what is the profitability, as what is the profitability of Amazon? Because that's the condensed question prompt. And it's a different prompt, so which looks like this. It's like, given the following conversation and the follow-up question, rephrase the follow-up question to be a standalone question in its original language. And then I provided the history and follow-up question, which is a question, the original question. And then this is the standalone, kind of summarizing chat plus what I'm asking. It's a bit confusing. So yeah, the first time you see this, it might take a while to wrap your head around this, but it is the RAG workflow basically, and LangChain actually makes this simple to implement once you understand the different pieces. So now let's do some fun stuff. So now that I have the chain, let's ask things that are in my documents. How many Facebook daily active users were there on average for June 2023? This is something that the model can only know if it has access to the external data source. So here you see what the model is doing, what the chain is doing for you. So it's going to get the files from Kendra and the excerpts that might be relevant to answer the question, to answer this question. So it kind of gets the meaning of the question by vectorizing it, and then gives me these three, the top three, and they all come from the meta PDF, as you see. Of course, because we're asking a question about Facebook, so he kind of understood that this is where where I'm getting that information from. And then you see that actually there is here the answer for my question somewhere in the document. So you see that the response at the end will be, let's print it. So according to the document excerpt, this is what the bot is telling me. The average number is for June 2023 was 2.06 billion. So here we go, a factual answer, recent data using RAG. You can try asking that in your Streamlit app to see what would the result be. Let's see, without the RAG, without going to Kendra, let's ask that. Oops. I pasted the extra character there. I'm just an AI. I don't have access to real-time data or statistics, but I can tell you based on historical data. According to Facebook SEC filings, the average number, okay, in actually what I think is happening is that it's hallucinating somehow. However, this model is from July, this Llama 2, right? So it could actually have this data. So this is maybe not the best example. So it could be that it's actually getting quite close. What do I get in the other one? So in the other one, I get the factual answer, which is 2.06. And it also tells me not only that, I have the source of truth, right? Because, okay, I will show you that after. So now I'm going to say, by how much does net sales increase in Amazon in the second quarter? Now it's going to look at the Amazon PDF and find three chunks that might be answering the question. And it rephrases my question to, well, actually, by how much did Amazon's net sales increase in the second quarter? Almost the same thing. It didn't need to rephrase much. And it finds, again, data from that document. And I can also say from where did it find that response. So now, because of the LangChain integration, LangChain can tell me, here is the document, here is the page number in that PDF. This is all indexed by Kendra. And this is how you can go back and check if your model is actually correct, or this is the source of truth, basically. Yep. So another just point I wanted to make, keeping your bot honest. So here it kind of tried to guess something. There is one approach many people use, which is like in the prompt itself, in the system prompt, like when I'm saying here, you are a grumpy bot, I could add something like, if you don't know the answer, don't speculate or don't try to answer, say, I don't know. Something like this. I cannot now, this is not going to work here, but you could add it in your Streamlit app to have this kind of prompt and check that it will actually much more often not hallucinate. And if it doesn't have a concrete evidence for something that you are asking, it will not respond. And actually it is already baked in some things like, what is the time right now? So this is things that he already knows that he should, oops, what happened? Okay, I lost my access. I think I lost my access somehow here. I think I need to relog into my studio. Yep, that's what happened. Or the workshop account I'm using timed out. Okay, need to go somewhere else. Oh yeah, the event that I was using finished. So sorry, I will not be able to continue. So I was using a test event for running these with you, but it just finished. So I would need to start deploying the model again and so on, because the account was terminated. But yeah, I hope you got some ideas.
Yes, definitely. Thank you so much.
No worries. And one
And
thing I
it's
want.
good to have a demo effect as well, because everything is planned and then you're feeling stupid when you're stuck into some
Yeah.
stupid part, and then this happens as well. So good.
And then you see that I'm also stupid.
No.
Yeah, so this is the feedback form. If you have like, it's very fast to answer. If you have 1 minute, please do provide us feedback.
We will publish our recording on YouTube channel later, next week, I guess. Wish you a good week.
Good week for everybody. And talk to you in 1 month. Bye bye.
Bye.